Hey grade 11, we're going to be starting a new outcome today, and this new outcome is called Reciprocal Functions. It's actually only one section in your textbook, so it's a very short outcome, a bit of a change from the last one we had. So what we're going to talk about with reciprocals, if you remember from last year, and please follow along in your note handouts, the reciprocal of a number is obtained by interchanging the numerator and the denominator of the number. Please feel free to pause the video at any time while you take any notes that you need. So again, you interchange the numerator and the denominator. So if you have 3/4, then the reciprocal is 4/3. So you just flip the fraction. If you have -200, the reciprocal would be -1/200, because -200 would technically be over 1. So again, if you flip that fraction, you get -1/200. Now, there are some tables below, so we can look at some key principles about the reciprocals of a number. So maybe just pause it here while you take a look at those tables. All right, while we're looking at the first little table, you should notice that the reciprocal of a really big number is really small, and the reciprocal of a smaller number gets bigger. On the second table, you should see that. The only number that has the exact same reciprocal as it did before is the number 1. So you can see that when x is 1, the reciprocal of x is 1. That's because 1/1 is still 1. On the second table, again, you should notice that if you have a small number like half, then the reciprocal of half is 2. So the reciprocal is bigger if your number started out smaller. You should also notice that the reciprocal of 0 is undefined. That's because if you had 0/1 and you flipped it, you'd get 1/0. And since we can't divide by 0, then that is not allowed as your reciprocal function. Underneath that, you should also have another table of some reciprocal principles. Now, these are things that you kind of need to know. So again, grab a highlighter or a pen and just, we're going to underline some of the key things, key principles of reciprocals. So first of all, the reciprocal of a positive number is still positive. So just because you flip the fraction doesn't mean the sign changes. So positive is still positive, and the reciprocal of a negative is negative. So the sign stays the same. We also said before that if you have a positive number between 0 and 1, you get a bigger number for the reciprocal. And if you have a smaller number to begin with, so the one that's close to 0, then the reciprocal is going to go to infinity. So again, if you have a small number, the reciprocal is going to be really big, and if you have a big number, the reciprocal is going to be really small. Another key one here is that 1 and -1 are the only numbers that are the same as their reciprocals. That's because when you flip them, you still get 1/1. And again, another very key one here is the reciprocal of 0 is undefined. So you really want to make sure you understand that anytime you have 0, 0 does not have a reciprocal. We call that undefined. So we also say that the reciprocal of a function y equals f of x, we'd write that technically as y equals 1/f of x. If you have a point on the graph of this function, that means that we'd actually flip the y value. So the y value is the part that would have the different, the flipped reciprocal. Again, as long as your point is not 0, because 0 does not have a reciprocal value. So for example, let's say you had a point that was 5 and -2. That was on the original graph. Then the point 5 and -1/2 would be on the reciprocal graph. So again, it's the y value that gets flipped. Okay, next I'd like to take a second to show you what this reciprocal graph would actually look like. So here we have video should be starting. So basically this is showing us that the reciprocal of 1 is 1 over 1, so it's still 1. So that point would still be on the same graph. The reciprocal of 2 is 1/2. The reciprocal of half, when you flip it, would be 2. So when you take the reciprocal of a smaller number, it's going to get bigger. Reciprocal of 3 would be 1/3. And you can kind of see that this graph is starting to curve a little bit. The reciprocal of 1/3 is 3. So it gets bigger. And all those values were positive originally, so they're still going to be positive. Then you can do the same thing in the negative. So the reciprocal of -1 is -1. The reciprocal of -2 is -1/2. The reciprocal of -1/2 is -2. So you can see the same kind of curve forming on the other side. So that would be something what a reciprocal graph would look like. So let's jump then to example 1 on your handout. For example 1, we have a bunch of ordered pairs, and now we want to make the ordered pairs of the reciprocal. Okay, so originally we have 5 and 3, so the reciprocal pair would be 5 and 1/3. Again, the y value is what's going to flip. For the next point, -2 and 1/2, we'd get -2 and 2 over 1, so 2. For the next one, we'd have 14, and then if you'd flip 0.2, you'd get 1 over -0.2, and 1 over -0.2 is actually -5. So if you take 1 and you divide it by -0.2, you would get -5. Then we take our next point, 0 and -10. So 0, that would be -1 over 10. And notice that it's okay to have 0 for x. That's okay. But if you look to the final point, we have -6 and 0. So that's where 0 is your y value. So we can't have that point because 6 and 1 over 0 would be undefined. So since this point is undefined, it would not be included in our solution set. Okay, the next example, we have to write the reciprocal of each of these functions. So basically, this whole function, you can think of it as over 1. So the reciprocal function would be 1 over x squared plus 3x minus 10. For b, same thing, we'd have to flip the fraction. So we'd get x plus 3, and then 3x minus 6 on the bottom. Try the last one on your own, please. And pause the video here. Then please check with the answer on the board, just to make sure you wrote it correctly. Okay, we just have a few more notes to take. We're going to talk about something called an asymptote. Now, an asymptote is a line with the graph of a function that cannot be touched. So please write the following down. And again, pause the video if you need to. Take some time to write this down. But basically, you can see that there is a blue dashed line. Those blue dashed lines would be the asymptotes. The green lines would represent the graph. So you can see that the graph does not cross those asymptotes, and the asymptotes are always represented by a dashed line. Now there's two types of asymptotes. There's vertical ones, so ones that go up and down, and there's horizontal ones, so ones that go left and right. So please write down the notes for the vertical asymptote and the horizontal asymptote. But basically, again, the vertical asymptote is up and down. So the up and down vertical asymptote occurs at the non-permissible values. And remember that the non-permissible values are wherever your reciprocal is undefined. So those are the places where you divide by 0. Now, in a reciprocal, that means the x-intercepts of the original graph are where the vertical asymptotes are then going to take place. Horizontal asymptotes we don't focus on very often in Pre-Cal 20 because it's a really big topic, and so it's focused more on Pre-Cal 30. But you should understand that a horizontal asymptote is just a flat horizontal dashed line. Next we have invariant points. So an invariant point is a point that doesn't move when you change a graph. So again, please write down those notes, and if you need to pause the video, please do so. We're going to do one final example today, and that's going to be example 3. So first of all, determine the reciprocal function. So again, this is the original function, and the original function would just look like a line. This is just a linear function. So the reciprocal of this function would be y equals 1 over 2x plus 5, again because you would flip that fraction. Now for part B, determine the equation of the vertical asymptote of the reciprocal function. Okay, the vertical asymptote would be where the x-intercept of the original function was. And you guys all know how to find x-intercepts. So remember, to find an x-intercept, you set y equal to 0. So we'd get 0 equals 2x plus 5. Subtract the 5 over, so we get minus 5 equals 2x. Divide by the 2. So that means that x equals negative 5 over 2, which is negative 2.5. So at negative 2.5 is where the x-intercept of the original equation is. Also notice that if I would plug in x equals negative 2.5 here, what would you get in the denominator? Okay, if I plug that in, I'd get 1 over 2 times negative 2.5 plus 5, which would give me 1 over 5 minus 5, which is 1 over 0. So you can't divide by 0, so that's why we get a negative, an asymptote at negative 2.5. So that is where that asymptote would occur, where the denominator equals 0, which is actually where the original function had an x-intercept. So for today, if you could please complete the textbook questions, page 403, number 1 to 3 AC, 4 and then 5 AC. I would expect those to be ready to go for Monday.